welcome back. We're in example 2 of our notes for central angles being measured in degrees. And in example 2, we're going to look at coterminal angles. Okay, coterminal angles are angles in standard position, which means their initial side is along the positive x-axis. The measure is determined by the location of the terminal side. The vertex is centered at the origin, which is the center of the circle. And angles in standard position are coterminal when their terminal side is the same, but their measures are different. Okay, so if we recall that there's 360 degrees in one revolution or one rotation around the circle, and we want to find a positive and a negative coterminal angle for 128 degrees, then if I add one rotation around the circle, that would be 128 degrees plus 360 degrees. So 360 plus 128 would be 488 degrees. And that would be a positive coterminal angle with 128 degrees. Okay, if I were to add another 360, 848 would also be coterminal with 488 and 128. I can keep adding revolutions around the circle, as many as I want. All of these angles, 1,568 degrees, 1,208 degrees, 848 degrees, 488 degrees, they are all coterminal with 128 degrees. Now, the directions tell us to find the coterminal angles closest to 0. So I don't want to keep adding 360. I want to give the answer that is closest to 0 in the positive direction and has the same terminal side as 128 degrees. So that would be 488 degrees. Now, to find a negative coterminal angle, I need to subtract 360, which would take me clockwise around the circle. So 128 minus 360. And that will give us the coterminal angle that is negative closest to 0, which is negative 232 degrees. Okay, again, I could keep subtracting if I wanted to find another negative coterminal angle. So negative 592 degrees is coterminal with 128. It's also coterminal with 488, right? All of these angles are just revolutions around the same circle. They have the same terminal side. Okay, in example B, to find a positive coterminal angle, I'm starting at negative 513 degrees. But if I add just one revolution around the circle in the counterclockwise direction, I still have a negative angle measure, and I'm asked to find a positive. So I would do my original angle, negative 513 degrees, plus 2 times 360 to get me 2 revolutions in the counterclockwise direction. And that gets me a positive coterminal angle of 207 degrees. So starting with my negative 513, this time to get a positive coterminal angle closest to 0, I needed to do 2 times 360. That's 2 revolutions around the circle. And again, that got us 207 degrees as our positive coterminal angle. Okay, then to find the negative coterminal angle, because we want to be closest to 0, I'm not going to subtract 360. Instead, I'm going to add 360, which gets me to negative 153 degrees, which is as close to 0 in the negative direction as. In example C, we want to find a coterminal angle over the interval 0 non-inclusive to 360 degrees inclusive, and we're starting at 1,115 degrees, and 1 revolution would definitely not get us there. 2 revolutions would be 720. That's also not going to get us to 360, so let's subtract 3 revolutions. So we'll do 3 times 360, and that gets us to 35 degrees. So 1,115, and then we subtracted 3 rotations around the circle. So 3 times 360, and that got us a positive coterminal angle of 35 degrees, and that 35 degrees is within the specified interval. Okay, then in example D, we're starting at negative 1,165 degrees. We want to find a positive coterminal angle over the interval 0 to 360. So we're going to need to add revolutions around the circle. And if I'm starting at negative 1,165 and I add 3 revolutions like we did last time, we get a negative 85 degrees, which is close but still not positive. So I would need instead to add 4 revolutions around the circle, and that gets me 275 degrees, which is within the specified interval. So we're going to add 4 times 360 to our original angle to get a positive coterminal angle of 275 degrees. Okay, example E asks us to find all coterminal angles, and there are infinitely many of them. So we're going to need to write an algebraic expression to capture all of the possibilities. So when we look at this angle, the terminal side is in quadrant 4. We can see from the direction of the movement, starting at the initial side, we're going clockwise to that terminal side, which makes this a negative angle. So the original angle is in quadrant 4, and in order to find its measure, we're going to need to look at the supplement of this green angle. Remember, supplementary angles add up to 180 degrees. So if I take the 180 degrees minus the one that I'm shown here in green, which is 115 degrees, that's going to get me the supplement. So we've got 180 minus 115. That makes the supplement 65. Only this is going in the negative direction, so this angle is negative 65 degrees. Now that's my original angle, and in trigonometry we often use this Greek letter theta to represent an angle measure. So this circle with a little line through it, through the center. Oops, let's try that again. It didn't get very big. Okay, so this circle with a line through the center, that is the Greek letter theta, T-H-E-T-A. So this expression, theta plus or minus 360 times k degrees, this k is any integer. So it's any positive or negative whole number, and those would be my revolutions. So my angle plus or minus any real number, any integer number of revolutions would represent all the possibilities. So my coterminal angles would be negative 65 degrees plus or minus 360 times k. And again, that's where k is any integer. You know, some textbooks, they prefer theta not be a negative angle when you're using it in expressions. So you may see, if you're looking up answers in a book, they're going to take that negative 65 and add 360 to get a positive coterminal angle to start with. So you may see the answer, like in a multiple choice question, for example, as 295 plus or minus 360k. And that's fine because negative 65 and 295 are coterminal angles. So this expression represents the exact same solution set as this expression does.